Hi, good morning, and welcome to the ZP Developer Zone weekly webinar. So I just making sure that we've got the audio going. So every week, Zimmer and Peacock does a webinar for our members, and Hasim Hassan mentioned to me that's probably the only, let's say, society or organization that actually does a weekly webinar for its members. So yeah, I can see that you guys are online, so nice to see you. So let me jump into it a little bit and say today's agenda is this. Hi Dima, Dima is here, cool. Thank you, Dima. So this week's agenda is I'm only going to talk quickly about the developer zone. We're going to do a two-part webinar. We'll do an introduction today, and we're going to do a main part next week. So let me just say hi to the guys online. Hi, April. And cool. Right, and then we'll do a main part next week, and then I'll do a summary. So what I'm going to talk about in a technical perspective this week is I want to say it's a disease or it's an infection called Candidiasis. It's a fungal infection that's caused by this Candida albicans. And we have a new member called Anti-Candida, and Anti-Candida is kind of interested in this. I think it's basically a fungus or a fungal or a yeast, and it's mostly in the gut of our cells, but unfortunately, if it kind of gets into the wrong places, then it can cause complications. So we'll introduce the topic this week about the biosensing of this, and then next week we'll sort of talk specifically about how to actually detect for it. So every week we do this, we do these webinars, and it's worth saying that these webinars are not just they're not just what things that I want to talk about, but actually they are definitely things that you guys suggest. So Anti-Candida has suggested that we talk about this yeast detection, which we're going to talk about. As you know, I have this new website coming up. There's also the ZP Academy, and I know that many of you have actually joined in on that website, so thank you for that. If you haven't, do it soon, because we're going to go quite live with it pretty soon. And we have the Academy and we have the Developer Zone, and you guys are members of that. It's probably worth saying that if you haven't done the Electrochemical Techniques for Biosensor Developers course yet, do it, because in this week and next week, we're going to start talking about impedance spectroscopy and enzyme sensors and antibody sensors. So that course will be particularly interesting. I noticed that I know April is online. So April, when you want to take the collaboration a little bit further, drop me a line and we can discuss that. So as I say, let's get into the main topic this week. So this Candida albicans, as I say, is a fungus or yeast, and the simple question is can we make a low-cost electrochemical biosensor for this? And in our time, we've talked about Sura disease, and we've talked about DNA detection, things like that. So the answer is yeah, we should be able to make an electrochemical sensor for it. The question is how are we going to do it? So we've talked in the past about antibody sensors and how to take kind of carbon electrodes and make them specific to particular analytes. So in the past, we've sort of said, we can immobilize antibodies to the surface of carbon. We said, in the absence of the antigen for the antibody, we can get a certain signal, and then in the presence of the antigen, that signal can change, and that can be the start of a signal. So we have had, long discussions about how to take screen printed electrodes and how to convert them then into biosensors. And I've talked about, the ZP hypervalue electrodes and how you can do that. And we've even discussed strategies on how to take that electrode, how to functionalize it, how to put the antibody onto it, how to put blocking materials onto it so that you block the non-specific binding. And we've discussed that. And we've also discussed it with gold as well. So I just wanted to kind of remind you guys, and I'll put this video up online later on because I'm not sure if any consumer is here at the moment, but I do want to kind of draw her attention to some of the work that we've discussed in the past, because I think it's now relevant to her interest as well. So the first thing I want to say is, so in the past, we have talked about taking screen printed electrodes, functionalizing them, and making them specific to the analyte of interest. Now, in this particular talk, we're talking about Candida. So I was thinking next week we're gonna drill into this a little bit deeper. But I think the things that I want to cover are, I'm going to do a couple of reviews over the next week and look at a couple of papers that I found. And one of them is here, where what they're in fact doing is they're taking a gold electrode and they're functionalizing it with the antibody. So we've definitely had conversations ourselves about if you can find an antibody specific to your pathogen. Like there is an antibody for E. coli, for example. There's even probably an antibody for listeria and things like that. If you can find an antibody for it, it's not so hard to then immobilize it, for example, onto a gold electrode. Now, what these guys are doing is they're actually using a technique called impedance spectroscopy. And it's So we will discuss this in more detail next week. But it's probably worth saying that I know in Indonesia there's at least 2 of these instruments, which are called the Anapot EIS. So the Anapot EIS allows you to then do impedance spectroscopy. Now, in that paper, what they're doing is, as they increase the number of pathogens in the sample, the signal's going from the green to the blue to the gray. They're effectively blocking and increasing the resistance of the surface and increasing the capacitance of the surface. So they're getting a binding, and then they're able to detect that binding using the techniques of impedance spectroscopy. So I was thinking next week we'll have to dig into that a little bit deeper. What they have here is what's called the equivalent circuits, that they've said the source of their signal, they call it RCT, and they can extract the source of their signal. And the RCT just means charge transfer resistance. So as they bind the pathogen to the surface, it increases the resistance. They can measure the impedance of the surface. They can extract a value called RCT, the charge transfer resistance, and that is the source of their signal. Now that is in one of the tutorials or one of the modules that we have on the ZP Academy. It is free. I know that many of you have enrolled. But in preparation for next week, if anyone wants to remind themselves about impedance spectroscopy, then it's worth taking a look at that paper. Sorry, that module. Now, because we're interested in Candida, I've sort of said to you, look, we've had conversations in the past about, you can, as long as you can find an antibody for your pathogen, you should be able to make an electrochemical sensor for it. But I also like to kind of say, that there's many ways of doing electrochemical detection. And this was another paper that I found, which I think we should discuss. Again, it's for next week to discuss in detail. But in this paper, they're basically breaking up the cell wall with an enzyme. So the Candida albican, they break up the cell wall with an enzyme, and in doing so, they release glucose. And so in the paper, what they're basically doing they're taking, and I'll just give you a direct demo of that. They're taking a glucose sensor and a glucose strip. Now this is the kind of quintessential, biosensor platform. They've obviously put the sensor into there. Now what I'll do is I will just, I know you guys are very familiar with this kind of technology. Just getting some blood. All right, so I've added my blood to that. There should be a countdown now. And we get the reading. And it's quite high because I've just had my breakfast. It's 8.7 millimolar. Now, what they've done in this paper is, rather than using the glucose in the blood as the source of glucose, they're actually using the cell wall of the yeast. They're breaking that down and then measuring the glucose. So I think the sort of logic of that is the more yeast you have in the sample, then the more cell wall you have to break down, and therefore the higher the glucose concentration. So that's quite a clever way of measuring the yeast. It's indirect, but it's quite a clever way of measuring the yeast. And then the other way that, so as I say, it's the glucose that's the source of the signal in this. The other way that I've seen that people are doing this, now we've talked, I always like these direct methods of measuring, let's say, analytes. So this Candida albican, it has molecules called quorum sensing molecules, QSM. And one of them is a molecule called tryptophanol. And that molecule is electrochemically active. So you can detect the pathogen, not directly, but actually indirectly through one of the molecules that it's in its quorum, or it's one of these QSM molecules. So I like that one because it's quite a simple technique. We've talked about cyclovoltammetry an awful lot in these webinars. And it's worth just saying that, again, there's another way now of just using quite a simple experiment to be able to detect something. Now, whether you detect the Candida by using antibody, which is probably the most specific way of doing it, but it's also the sort of most complicated assay. You can do it that way. You potentially do it through the breakdown of the cell wall into glucose and measuring the glucose. That's I would describe it, sounds like a fairly simple way of doing it. But the easiest way of doing it is actually to try and detect these tryptophan. But the only issue then you would have is how specific is it? Because obviously, if there's other sources of this molecule in the sample, then it will kind of confound the result. But it just shows you that there are always many ways of making electrochemical biosensors, and some of them can be quite hard, some of them can be quite easy. And which strategy you adopt really depends on the specificity of the assay that you want to do. So what I was thinking is we would introduce the topic for next week, this week, and then actually go through these papers in a lot more detail then. And I wanted to kind of give any consumer a bit of a heads up that we were going to dive in quite deeply next week. And so I wanted her to be kind of maybe taking a look at these papers before we get there. And as I say, that tryptophan is electrochemically active. So I appreciate Abril and Dima joining us this week. I'm just going to do a summary. So what I really want to talk about is next week, and then we're going to dig a bit deeper now into. We've discussed Abril's kind of pathogens and interests in the past. And now we're going to have a little bit of a series on this fungal yeast problem. So next week we are going to dig into, we're going to revise impedance spectroscopy because we can probably detect the binding of the pathogen using its antibody. It's also quite good because we can actually look back at glucose sensing as well, because glucose sensing is still the biggest application of biosensing in the world. So it's quite nice that we can actually use the detection of Candida albican as an excuse to also look at glucose sensors again. I think it's quite nice to kind of go back over that work. And then I will also say, because I also want somebody to get quick results. Hi, Annie. Hi, Annie. I will put this video up online in a bit. And we were just discussing that we're going to do, this week we've reviewed that. Really what we're going to do next week then is dig into this a little bit, a bit more in depth. So next week's topic is going to look at Candida albicans in more detail. We're going to look at it using impedance spectroscopy. We're going to look at it using the breakdown of the cell wall and the production of glucose. That's another way of detecting it. And also in the quorum, there's a molecule called tryptophan. And we can probably directly electrochemically detect that. And it's probably the reason I want to sort of discuss these three things next week is because one of them is going to be very easy, is the detection of tryptophan. That should be quite straightforward. So it would mean that, you know, you can kind of go in the lab, get a quick result, get some confidence, you know, that things are working correctly, and then discuss, and then sort of, you know, is that assay working? Yes, no. If it's working, yes, but it's not specific enough, then you can start thinking about, will I detect this this yeast through the breakdown of its cell wall, the production of glucose and the detection of the glucose, or actually, am I going to make myself an antibody-based biosensor and use potentially techniques like impedance spectroscopy to actually detect it? So we're going to talk about these three strategies next week, and I'm just going to kind of zoom in a little bit and say, whoops daisy, there's a particular course that's probably worth having a look at before next week. I am going to use next week as an excuse to revise impedance spectroscopy. There's a particular course on the ZP website called Electrochemical Techniques for Biosensors Developers that's worth looking at. So Annie, we did this webinar. First of all, welcome to the ZP Developer Zone. We did this webinar for you this week. We're going to do the webinar in two parts. This week was a kind of introduction to kind of give you a heads up about what we'll discuss next week. And then next week will be a bit heavier because then we're going to kind of really get into the electrochemistry of this. But for us as a ZP developers, it was quite nice because we have covered some of these topics in the past when we've discussed work with Abril, for example. These kind of things have come up in the past. So it's 20 past 8 a.m. in London at the moment. Hasim's just turned up. So Hasim, I'm just going to do a quick summary for you. That it was nice that Dimar and Abril were here so that they know what we discussed. But I want to just say to you, Hasim, that next week we're going to discuss 3 topics. We've introduced them this week, but we're going to look at Candida albicans. We're going to look at it using impedance spectroscopy. I'm going to touch on the antibody EIS, and I want everyone to know that you know where these instruments are in Indonesia, so it's worth letting if the guys want to get at these instruments, I want them to know that you know where they are. We're going to talk about detecting the yeast through the glucose that's in the cell wall, so we can break up the cell wall and detect it using electrochemical technology. Using glucose technology. But also, Hasim, you can also detect it using direct electrochemistry of the tryptophan, which is in the quorum. So these kind of yeasts or fungi have something called the quorum, and in there's electrochemically active molecules. So we're going to cover these 3 papers and these 3 topics next week. I'm going to use it as an excuse to go back over glucose sensing, go back over impedance spectroscopy, and also go back over just cyclovoltammetry because it's so simple. So Annie and Hasim, yeah, definitely next week will be, especially for Annie, will be a good one for next week. And yeah, it's like I say, it's 20 past 8 now in in London. I appreciate you guys. You always come every week. It's great. We will carry on trying to make every week doing something that's useful to our members. And as I say, Abril, I know you're on my mind at the moment because I know you want to do a next round of collaboration, and I'm happy to be doing that. So thank you, Dima and Eni and Hasim. And, it's good of you guys to come. And any questions, I'll be in the chat room. I'll also put this video up in a few minutes. Well, yeah, in a few minutes on YouTube. And then, because I want to do that because I want Annie to be able to see the whole content. Okay, cool. All right, well, thanks, guys. I appreciate it. And I will see you next week, and we'll do a much more dig down into the detection of Candida albicans. All right. Yeah. All right. Cheers, guys. I appreciate it, and I will. We'll see you all next week.